So today we're going to go over the concept of fluid statics, and we're going to look at 4 different approaches whereby we use fluid statics calculations. So the first one we're going to look at is hydrostatic force on a horizontal plane. And with this one, we're going to need to calculate our pressure, force values, and our horizontal force. So with the pressure, the formula we're going to have is gamma times H for the pressure, and for the force, we know that our force is pressure times area. So to solve for our resultant force in this case, we're going to have gamma H times area. So from there, we move ahead to this question and we ask, is pressure uniformly distributed on the sides of the forces? And the answer to this question is no, because the pressure increases with depth. So our next approach we're going to look at is our hydrostatic force on an inclined surface. And with this one, we know that our resultant force is going to be our gamma HC times our area, whereby normally we know our HC is supposed to be equal to our YC, but in this case our YC is going to be our HC sine theta. So this is the height times the sine of the angle. And with that, we can also solve for our YR, and our YR is normally YC plus IXC over YC times our area. So when we have all this, we can go ahead and solve for the moment, the sum of the moments, which we know from prior classes is our resultant force, in this case, times our YR, because we're going to measure the YR over here. Because the resultant force is going to be at that YR position. We're going to measure it and multiply it, which is because we know our moment is force times distance. We're going to multiply it by the distance to the end of the gate. So our third approach we're going to look at is the pressure prisms approach. And with this approach, we're going to have to calculate the forces, because we can see on this surface we have our force acting on the side of the wall, and we also have a force acting up upon the wall. So we're going to have 2 different approaches for this. So with the pressure prisms approach, to find our force, our formula we use is 1/2 gamma H. And in this case, our gamma here is oil. It could be water or any other substance. So it's going to be 1/2 gamma H times our breadth times our height, which is our area. So in this case, we're considering our substance to be a rectangle, which that's why we have breadth times height. And to find the F2 is just like what we did for our hydrostatic on horizontal plane. So it's just going to be gamma H times A in this case. And H is normally a YC. And YC, we should know that is normally the center of the force, of the liquid whereby the forces are acting. Depending on the shape of the forces being applied. So our fourth approach is our decomposing forces on a curved surface. And with this one, we can also see that we also have 2 different approaches where we're going to use for calculating this. So I've labeled the forces on the side, whereby we know we have our F1 here, and we have a horizontal force acting on the side of the curved surface, and we have a vertical force acting upward, and also another vertical force acting downward, which is the weight of the substance. So with this one, our F1 formula we're going to use in this case is going to be the same as the pressure prisms, because we are considering our sum of forces in the X to be F1 and H, and they are opposing each other, so equal and opposite forces are equal to each other. So therefore, our F1 in this case is going to be gamma, and 1/2 gamma again, like the previous formula. So 1/2 gamma H, then times our breadth times our height, whereby this is a rectangle, for example, again. And for our forces in our Y direction, we're going to have our force of our weight and a vertical force. So in this case, we know that the formula to find the weight force is gamma times our volume, whereby our volume is our area times height for this example. So therefore, that's the formula we're going to use. So that's going to equal to our vertical force. And for this particular shape we're using, we know our area is pi r squared over 4. So that should be it for the 4 different types of fluid statics approach and finding formulas. Thank you.